Hi there, Mr. Dunaway here. Welcome to Chapter 5, Section 4. We're talking about point-slope form of an equation. If you're at this point, you hopefully have an understanding of slope-intercept form, and we're going to take a look at what happens when you don't know what the y-intercept is, and you still have to get an equation, which we are able to do. So let's jump right into things here. You should have this in front of you, and let's take a look at what the first thing says on our paper here. It says circle the equation that has a y-intercept of 3. So what we're going to do is we're going to review right here y-intercept of positive 3. So this goes back to what you're supposed to know, y equals mx plus b, where m is the slope of the line, b is the y-intercept of the line. So we know the point that goes through the y-axis, and they want that to be 3. If I look at the first one right here, that's my problem right there. That's a y-intercept of 4, so that's not the answer right here. This one looks pretty close, except it's minus 3, making the y-intercept negative 3, so it's not that one. This one says plus 3 right there, so that looks like that is my answer. That has a y-intercept of positive 3, and that y-intercept is 2, so that is not a solution to that particular question. And number 2 says, as we continue review here at the beginning, it says circle the equation in slope-intercept form. So here I'm looking for that y to be isolated all by itself. In the first one on the left, clearly not, as it has 2x minus y, as well as the second one that's got x plus 3y, so clearly that's not. This one is actually in a form that you're supposed to be able to recognize after today, called point slope form, but the problem is it's got that minus 4, so that is not in slope intercept form. So that is not what we're looking for in this question. This is the only one in slope intercept form, y equals 2x plus 6. And then number 3 at the last part of this review says circle the statement that is true about the y-intercept. So this is actually something you do need to be aware of. As we consider what is a y-intercept, you're basically looking for any point on the y-axis here. And as we consider these points, like let's say that that's the point 0, 1, okay, and then another point up here, so we have some space, that might be the point let's say 0, 5. And I could pick any point up here. I could pick a negative point. Let's say that that's 0, negative 3. And as we consider what an ordered pair is, it's a value of x, y right there. We'll notice that all of the points on the y-intercept, again, we're talking about the y-intercept here in number 3. It says circle the statement true about the y-intercept. All the points on the y-intercept, the x value is equal to 0. You see that in my example here, 0, 5, 0, 1, 0, negative 3. So we're looking for a value where x is equal to 0 for the y-intercept. Okay, so this first one, right, so it says circle the statement that is true about the y-intercept. Does it occur where y is equal to 0? Well, no, that's actually the x-intercept where y is 0. Occurs where x equals 0 on the graph. That is true, as I showed you in the example over here. And the third thing says occurs where the graph touches the x-axis. No, we want it to touch the y-axis. So the middle one is the only one that is true in that third review question. And then quickly here, review of what a function is really what we're talking about in all these equations we're learning in Chapter 5. It's the input. This is just a nice visual that we've seen a couple times where you input a value, the x value goes into an equation, and this just represents an equation. It might be like y equals x plus 1, and it outputs a value in that example. Whatever x is, it would be x plus 1, and the output is y. So that's a picture of what it is happening when we look at a graph. If you put in an x value, you get an output there. Okay, so with that said, this bottom part, not concerned with that. I'd prefer to move on as this material gets a little bit tricky. It looks much harder than it actually is today, and it's going to take you some time to study it to master the content. It's pretty normal to have people struggling at this, and you have to keep up and ask questions to get through it. Because here is today's key concept. Highlight this or underline this. This is what we are learning today. Point-slope form of a linear equation. That my highlight did not show up very well there, but you get the point of what we're trying to learn there. Here, point-slope form. All right, well, let's consider what that's called, point and slope. Okay, so what that means is you know a point on your line. However, in this equation, it does not have to be the y-intercept in this new form, but you do have to know what the slope is. So you need to know any point on a line and the slope, and you can create an equation called the point-slope form, which is what we're learning today, the point-slope form. All right, point-slope form is of an equation is of a non-vertical line, has slope m. Okay, so we're still using the m, and it goes through some point, and notice what they call the point right here. It says x sub 1, y sub 1. Okay, so that just represents a point on the line. Okay, so number 7 says, in the above, what does x1, y1 represent? Well, that means that it's a point you know on a line. Okay, you have to know one point. It might be the y-intercept, it might not be today, because today we can use this equation to find it if it's not the y-intercept. Okay, what does m represent? M represents the slope. Okay, so if we know some point on the line and we know the slope, this is the magic formula right here. Y minus y sub 1 is equal to m parenthesis, which is times x minus x sub 1. And remember that x sub 1, y sub 1, that just means some point on the line. It means one point you know on the line. Consider this, if x sub 1, y sub 1 is one point on the line, well, what do you think x sub 2, y sub 2 might mean? Well, that would be some other point that's different from x sub 1, y sub 1. Okay, so that would be a different point that is on the line. So that's another specific point that you know on the line. And we actually see that, and you saw that when we learned the slope formula not too long ago. Okay, so the magic formula again, it's y minus y sub 1 is equal to m, the slope, parenthesis, x minus x sub 1, where x sub 1 and y sub 1 are a specific point on the line. So if this says in problem 1, it says, got it? It says a line, let me do this because I want you to focus on what I'm looking at here. It says there's a line that passes through 8, negative 4, and has a slope 2/3. What is an equation in point-slope form of the line? Okay, so this question is asking me to use point-slope form. And the clues that they've given me 2 clues, a point and the slope. Okay, so they want us to find that equation. All right, it says, next it says use the point-slope form of the equation for the line 8, negative 4, and has slope 2/3. Okay, so this says circle x sub 1 and underline y sub 1. Okay, now we could go up here and we could see that this 8, that's x sub 1. That's the x value. It's a point on the line because it tells us the point passes through that, and that's y sub 1. So they asked us to circle x sub 1, which is 8. So that's right here. Okay, that's what they're doing. They're just trying to get you to think through the formula. That's x sub 1. And then it says underline y sub 1. So I'll put an underline under negative 4 because that's the y sub 1 value. All right, this 2/3, that's the slope, and this 12 has nothing to do with our particular equation. All right, now it says basically it's saying take that and substitute that into point-slope form, which we had right here. Okay, and again, before I go on, let me just point out again that x sub 1, y sub 1 is a specific point. And you might be asking yourself, and you should ask yourself, well, what is the x and the y then? Because x and y, this x and y right here, well, what does that represent? That represents basically all the other possible points that make up the line. Because there's an infinite number of points that can make up this particular line. Consider if you put in one value for x, you could solve it and get something different for y. So here on number 10, all we're doing is we're substituting this in. Okay, this y, we just keep as y. You keep that as y because you have to represent all the infinite points that make up the line. So those are a variable. All right, y sub 1, that's the negative 4. So it's y minus negative 4. The m is the slope, which is up here. They gave that to you in the question, 2/3. X minus x sub 1 is 8. Okay, so the equation for the line is y minus negative 4. Now, since it's minus negative 4, I would prefer to write that plus 4. Instead of having the two negatives next to each other, we would rather just say y plus 4 equals 2/3 times the quantity x minus 8 is fine. And there you have an equation of this line in point slope form right here. Okay, so I'm a little bit over my time for this part 1. We have a little bit more to do for today. So I'm going to stop this video and start another one here in a moment. And hopefully you're able to keep up. And we'll start here in a moment.